Hi everybody. So in this video, we're going to look at L'Hopital's rule. And this is a mathematical technique used for finding the limit of an indeterminate form, such as 0 divided by 0 or infinity divided by infinity, when evaluating limits in calculus. So if you have a limit of the form f of x divided by g of x, where both f of x and g of x approach 0 or infinity, as x approaches a certain value, let's say c, then the limit, as x tends to c, of f of x divided by g of x is the same as the limit as x tends to c of the first derivative of x divided by the first derivative of g. In other words, you can take the derivative of a numerator and the denominator and reevaluate the limit. Okay, so as we work through example 1, if we were to try and evaluate this directly, as x tends to 0, then we'll have the sign of 2 times 0, which is the sign of 0, divided by the sign of 3 times 0, which is also the sign of 0. And we know that the sign of 0 is 0. So this will be 0 divided by itself, which is undefined. So for this reason, we can use L'Hopital's rule. So if we say that f of x is equal to our numerator, the sign of 2x, then the first derivative, f dash, using the chain rule, will be 2 cos of 2x. For our denominator, if we say g of x is equal to sine 3x, then g dash of x will be 3 cos 3x. So now we can evaluate the limit as x tends to 0 of f dash of x, 2 cos of 2x, divided by g dash of x, so 3 cos 3x. Now as x tends to 0, this 2x will also become 0, and the cos of 0 is 1. So our numerator becomes 2 multiplied by 1, which is 2. Our denominator, well again, as x tends to 0, 3x will tend to 0, the cos of 0 will tend to 1, and then we'll have 3 times 1, which gives us 3. So as x tends to 0, the sign of 2x over the sign of 3x will converge on 2/3. Okay? So for example B, if we were to try and evaluate this directly, we'll have the limit as x tends to infinity. Our numerator will be infinity squared. Our denominator will be e to the infinity. Infinity squared is infinity, and e to the infinity is infinity. So again, this will become undefined. So then using L'Hopital's rule, we'll say f of x is equal to x squared. So f dash of x will equal 2x. G of x, the denominator, is e to the x. So g dash of x will be also e to the x. So now we'll have a limit as x tends to infinity of f dash of x, 2x, divided by g dash of x. We'll substitute in infinity, so we get 2 lots of infinity, which is infinity, divided by e to the infinity, also infinity. So for our first derivative, this is still undefined. But what we can do now is work out the second derivative. So f double dash of x will be 2, and g double dash of x will again be e to the x. So now we'll have a limit as x tends to infinity will be 2 divided by e to the x, which is e to the infinity. E to the infinity is infinity, and 2 divided by this becomes 0. So 2 divided by a very big number becomes 0. Okay? So the limit as x tends to infinity of x squared over e to the x will converge on 0. Okay? Let's move on to question 2. So in example 2, we've been told to work out the limit as x tends to infinity of the natural log of 1 plus 2x all over x. If we were to try and work this out directly, we'll have a natural log of 1 plus 2 times infinity, which is infinity. This one becomes negligible, so we'll have infinity over x, which is also infinity. The natural log of infinity is infinity divided by itself, undefined. Okay? So we'll use L'Hopital's rule here. We'll work out, or we'll say that f of x is the natural log of 1 plus 2x. We can differentiate this using the chain rule. So f dash of x, the derivative of a natural log is 1 over the function 1 plus 2x multiplied by the derivative of this inner function, which is 2. So this becomes 2 over 1 plus 2x. For our denominator, if g of x is equal to x, then g dash of x will equal 1. So now the limit as x tends to infinity of f dash 2 over 1 plus 2x divided by g dash of x, which is 1. Now as x tends to infinity, we'll have 2 times infinity. This 1 becomes negligible, and 2 divided by infinity is 0. And then we'll have 0 divided by 1, so this will approach 0. Okay? Let's try one more question, example 3. Okay, so for example 3, this is a little bit more complicated. So the way we're going to simplify this, and we've been asked to work out the limit as x tends to 0 of 1 minus 4x to the power of 1 over x. The way we're going to simplify this is we're going to say that this is equal to y. And because we've got a unknown as a power, we're going to take the natural log of both sides, and that will pull this power down. So we'll have a limit as x tends to 0 of a natural log of 1 minus 4x to the 1 over x is equal to the natural log of y. So the limit as x tends to 0, pulling this power down, we've got 1 over x times the natural log of 1 minus 4x is equal to the natural log of y. So now we can put this in this form by writing the limit as x tends to 0, the natural log of 1 minus 4x over x. And this is equal to the natural log of y. So now we can say that f of x is equal to 1 minus 4x. So f dash, using the chain rule, will be 1 over 1 minus 4x multiplied by the derivative of the inner function, so negative 4. So this becomes negative 4 over 1 minus 4x. And we know g of x is x, so g dash of x will equal 1. So now we'll say the limit as x tends to 0 of f dash of x negative 4 over 1 minus 4x divided by g dash of x is equal to the natural log of y. We'll substitute in the 0. The 4 times 0 becomes 0. So this is negative 4 over 1 divided by 1. So this becomes negative 4 is equal to the natural log of y. But what we want is y. So if we take e for both sides, these two will cancel. So e to the negative 4 will equal y. But we said that y is the limit at x tends to 0 of 1 minus 4x, all to the power of 1 over x. So we can erase this and put in what we found for y, e to the negative 4. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe. And you can download the full lesson and worksheet from my website, missmathematics.com. There's a link in the description below. Thanks again and take care.